let's talk about separating the substances of a mixture. If you take a look at the warm-up, it says a student scoops up a pail full of water and mud from the bottom of a pond. The mixture in the pail is a suspension of mud particles and algae cells and a solution of salts. Outline a method for separating the three components. Okay, so first what we'd probably want to do is filter out the largest particles that we possibly could. So I would filter the mud particles out. Second thing is I would try to remove the algae cells, and I would probably do that through centrifuging. When you centrifuge something, you separate it by density. And number three, if I want to get the salt separated from the water, you want to evaporate the water to leave the salt behind. Okay, so today we're going to be talking about separating mixed substances, and most materials are mixtures. Our atmosphere, our natural water, the ore, petroleum products. Mixtures can be unmixed, and since the ingredients of a mixture are not chemically combined, they're going to retain their own individual properties or identities. And the trick is going to be to separating the substances of a mixture is picking a property that differentiates it from something else. So we're going to move on and come down here to mechanical means of separation. So a physical separation doesn't involve a chemical reaction. And this would be things like centrifuging something. That's where you spin it in tubes and it separates based upon density. And we've got chromatography, which is where you let mixtures separate based upon polarity. And recrystallization, decanting, that's where you pour off a liquid that's on top of some solid mixture that's at the bottom. Density separation, distillation, that's where you separate by boiling point. Electrophoresis, evaporation, extraction, flotation, filtration, we keep going. Freezing, magnetic separation, reverse osmosis, and sedimentation. These types of separations can be classified as being mechanical or non-mechanical. Non-mechanical separation techniques are where we're going to be using things like heat, electricity, or magnetism, or dissolving. Mechanical separations are going to be things like where we use gravity or motion. Maybe we pick things out. Maybe we sift it. Maybe we filter it or shake it, spin it, or pour it. Okay? Let's move on to density separation. Density separation is where we're going to have some sort of a sediment, so something that falls or sinks to the bottom of a liquid. And a medium is going to be exerting an upward force called buoyancy on objects that are immersed in it. And when an object enters a fluid, it lifts the fluid that it displaces. And the buoyant force equal to the weight of this displaced fluid is redirected upward on the immersed object. If you go to the next page, every object surrounded by a fluid has at least some of its weight supported by buoyancy. And if the object is less dense than the fluid, then the object will float, and it'll displace the weight of the fluid that's greater than its own weight. And if we move down to decanting, this is a sort of density separation. Decanting is when you carefully pour off the liquid and you leave the sediment in the bottom of the original container. And sometimes you'll use a stir rod to pour the liquid off, and the liquid will flow down that stir rod into the other container. Sometimes you're going to have a small amount of liquid left in this original container, so you have to be careful not to pour off that sediment, and you want to keep it from flowing into the other container with the liquid. You can also separate the sediment by filtration, and the liquid containing the sediment is usually swirl it to get it all mixed, and then you pour it into a folded piece of filter paper in a funnel, and then the part that comes through, the liquid that passes through that filter paper is your filtrate, and then the part that you filtered out, the solid part, is known as the residue, and that stays on the filter paper in the funnel. And some dissolved substances are too small to be filtered out by regular filter paper. Some colloids can be removed by ultrafiltration, which uses filter paper with really small pores. Let's talk about centrifuging. This is another mechanical means of separation. That's where we spin something and we separate it based upon density. It's kind of like if you're in the car and you're in the back seat and somebody turns a sharp corner and you get thrown sideways in the back seat. That's sort of similar to what's happening with the substances that are in the test tubes here in your centrifuge. So as the tube is getting spun, the suspended particles are going to end up separating based upon gravity. If you take a look at the next page, let's take a look at the quick check here. It says, what force causes objects to float? That would be buoyancy. What is decanting? This is where you pour off liquid and leave sediment behind. Number 3, how does centrifugation work? Well, the particles in the tube travel in a straight line while the tube turns and spins. And the spinning forces it to the bottom of the tube. Let's talk about chromatography. Chromatography separates things in a solution by having them carried up a stationary phase. Typically, for us, it's going to be a piece of chromatography paper. And they travel based upon polarity, and are they more attracted to the paper or the solvent that is being used that is traveling up the paper. And so the mobile phase is the phase that is traveling up the paper. The stationary phase is the part that is not moving. So what you're going to have is there are different forms of chromatography: gas chromatography, column chromatography, thin layer chromatography, which is abbreviated TLC, paper chromatography, which we use. And you put a drop of the solution that you want to separate near the bottom, usually like a centimeter or 2 up from the bottom of the chromatography paper. You usually put a little X with a pencil, or you put a line across with a pencil, because a pencil will not bleed, but a pen will. And you put a dot of your solution, a small dot, on that X or on that line that you want to separate. And then you take your chromatography paper and you have the bottom of it just in the solvent. You don't want to submerge the part where you have your mixture or your sample, because it'll make it bleed. And what happens is, through capillary action, the solvent is going to travel up the paper. And if the solvent is polar, let's say, and you have polar substances in your mixture, then they may travel with your solvent up the paper and separate accordingly. Versus if the substances in the mixture are non-polar, they may not be as attracted to that solvent, so they may stay further behind. And you can see this progress happen as the capillary action is pulling the solvent up and up and up that paper. You'll notice that my mixture is separating into 3 different substances. Okay, you could say that this substance, since this is a polar solvent, is more attracted to that polar solvent. That's why it's traveling further up the paper with the solvent. Whereas this one down here is less attracted to the solvent and more attracted to the paper, which is why it is staying further behind and not separating or not traveling as much. Now, what typically happens is we are going to be calculating something known as an RF value or a retention factor. And this is the distance that the substance travels versus the distance that divided by the distance that the solvent travels. So if I wanted to calculate the RF value for this substance here that had separated, it traveled 2.7 centimeters from my pencil line, and then the solvent traveled 5.4 centimeters. So you would take 2.7 divided by 5.4, and you would get your RF value, which is unitless because the units cancel. And we can use RF values to help us identify substances in a mixture, okay? Now, electrophoresis is something that is often done in biology or in a biochem lab. And electrophoresis is similar to chromatography that has a stationary phase, a non-moving phase, which is a gel. And in chromatography, the chromatography paper is your stationary phase. And the gel is placed in a dish with oppositely charged electrodes at either end. And the species that are in your mixture are separated by the charge or their polarity or their mass or their size. And there's a really, really useful way for separating substances in the lab. Now, if we're talking about distillation, distillation is any process that separates a mixture by using their different vapor pressures or boiling points. And this requires heating the sample. You typically have it in a flask. And then as you reach the boiling point of one of the substances in the mixture, it will begin to vaporize, and then you will collect that in a container. The vapor will travel down a tube, and then it will condense back into its liquid, and you'll collect it in a test tube, and you track the temperature as you go. Now, the part that you're pulling out is known as, or collecting, is known as the distillate. And the impurities that were dissolved in your solution usually remain in the original flask. This is known as your residue. And this is a really great way for separating a liquid mixture. If you have a mixture that can't be completely separated by a simple distillation, it's known as an azeotropic mixture. This is a laboratory distillation apparatus. The one that we use is not as fancy. Yes, we have a flask. We typically use a hot plate. We have simple plastic tubing to collect the part that's vaporizing and to have it travel down into test tubes. This is an example of just typical like organic chemistry distillation apparatus. Oil refineries use distillation to separate hydrocarbons in crude oil with similar boiling points. And if we go on to the next page, here we have froth flotation. Precious metals like gold and silver are really stable and unreactive in nature. And copper is found in nature, typically in salts. And naturally occurring compounds are known as minerals. And rock that contains a desired mineral is called an ore. And the first stage of mining is where you extract the ore by blasting or drilling. The second stage is where you crush the ore into a fine powder. The third stage is where you separate the minerals from the rest of the ore. And we can do this by something called froth flotation. So if I want to separate copper compounds, I would use this. So that's where we mix the powdered rock with water and then a little bit of an oil. And the oil is going to stick to the minerals. And the oil, since oil and water don't mix, the grains become hydrophobic and they float on water because they repel water. And that air is bubbled through the mixture, and then we can pull off those grains, which are now air bubbles that are floating on the surface. And we just skim it off, we wash it, we dry it, and we ship it to a refinery. We also use froth flotation in wastewater treatment and paper recycling. If you take a look at the quick check, it says, what is chromatography? This is a technique that separates substances in a solution by having a flowing liquid carry them at different rates through a stationary phase. And the stationary phase for us will be paper. Number two, what is distillation? This is where you separate a mixture using different vapor pressures. I'm going to abbreviate that with BP, or boiling points. I'm going to abbreviate that with BP. Name 3 areas that use froth flotation. This would be mining and wastewater treatment and paper recycling.